So, we've seen how to compare fractions if you have a number wobble handy. But what if you don't? Or what if the fractions have some mixed numbers in them? Well, I'm going to show you another way to compare which fractions are bigger than others. This question says, put these fractions in ascending order. Ascending means normal order, from smallest to biggest. Before we can do that, I notice we've got all fractions in different kinds here. We've got some that are proper fractions, and then this mixed fraction. This mixed fraction here, let's get it to an improper fraction. One number divided by another. Then it will look like the others, and the problem will be easier. It says 1 1/2. How would I write this as a mixed fraction? Well, the denominator will be 2, and the top will be 1 times 2, which is 2, plus 1, which is 3. So I've got 3 halves here, 1/5, and the last one is 3/10. There we go, that's better. Now they all look the same. Maybe you don't have to do this step if you don't have mixed numbers, but at least now they all look similar. Okay, so step 2, we need to get the lowest common denominator, and that is the smallest number that is a multiple of each denominator. Which ones are the denominators? They are the bottom numbers, 5, 2, and 10. What is the smallest number that is a multiple of 5, and it's also a multiple of 2, and it's also a multiple of 10? The lowest common denominator is 10. Okay, so now we know that the bottom number really should be 10. That way they can all look the same. They'll all have the same bottom number. This is 1 over... So I'll actually write that in. Divide by 10, divide by 10, divide by 10. And that's what they're all going to look like. So we don't have, different kinds of fractions which are harder to compare. This says 1 over 5, but I want the bottom number to be 10. What do I have to times by to get from 5 to 10? I have to multiply by 2. So the bottom gets multiplied by 2. 5 times 2 is 10. And the top gets multiplied by 2. 1 times 2 is 2. Okay, let's try another one. This one, the bottom number was 2. We want it to be 10. What do I have to multiply 2 by to get 10? 5. So I'm going to multiply the top by 5 as well. 3 times 5 gives me 15. Finally, this one is already over 10. I don't have to multiply by anything. To get from 10 to 10, I can multiply by 1. I don't actually have to change this last one. So I can just leave it as 3 over 10. Isn't this cool? The reason I did this is that now they're all out of 10. Now it is really easy to see which is the smallest and which is the biggest. Which of these fractions is the smallest? The smallest one is 2 out of 10. And which is next biggest? The next biggest one is 3 out of 10. And which is the largest number? The largest fraction is 15 out of 10. So these are the fractions in order. 1/5 is that one. 1 1/2 is this one here, 15 out of 10. And 3/10 is that one. Now you might get a different kind of question, which is to write them on a number line. And even if you don't, it's useful to think about a number line to see which of these numbers is bigger or smaller. Now, first of all, I notice that we've got numbers, a number here that's less than a whole, another number here that's less than a whole, and this one here that's bigger than a whole. It's a lot bigger than 1, but less than 2. So we need to go from 0, 1, and 2. So some of them will be here, and then that mixed fraction will be somewhere in here. The bottom number, the lowest common denominator, is 10. So we're going to break each whole part, this 0 to 1 space, into 10 equal parts. You might notice that if you're on a grid, I've put a grid paper here, because if you've got grid paper, graph paper in your book, it's so much easier. Notice that I've made it so there's 1, 2, 3, 4, 5 spaces. And the reason is, well, partly, one of them was fifths, but also then I can cut each of them in half, and now they are in the 10 pieces that I need. If the lowest common denominator was different, like 12, then of course I need 12 pieces. But here, LCD is 10, so I'm going to break it into 10 equal pieces. And I can do the same for the rest. All right, well, the first one is to write 2 out of 10, or 1/5. Where would that be? Well, one way is to think of 1/5 as being 2/10 because they are the same. 1/5 is 2/10. There's 1/10 and there's 2/10. Another way that you might like to think of it is, well, from 0 to 1, there are 5 squares there. And it's one of those 5 squares. It's 1/5 the way from there to there. All right, well, let's try another one. Let's do 3 out of 10. 3 out of 10, well, this is already in tenths. I can just count 1, 2, 3 because it's already in tenths. Okay, the last one to do is, well, let's do the biggest one, which is 1.5. 1.5 is the same as 15 out of 10. 2 different ways you can do it. You can count 15 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and end up here. Or you can think of it as 1.5, which is 1 whole and an extra half. So I'm halfway between 1 and 2. So here is how you can compare fractions even without a number wall. And here is how you can write the fractions on a number line by first breaking up each whole unit into the number of parts that you need. The number of parts from the lowest common denominator. Have fun. Do let me know if you have any questions. Bye, everyone.